Okay, so our next look at multi-step inequalities will involve what happens when we have variables on both sides of the inequality sign. So for right now, I'm going to get you to ignore the graph down at the bottom. We're going to fix that once we actually solve it. So if I look up here, I've got 6n minus 1 is greater than 3n plus 8. And just like when we are solving an equation of this type, we want to isolate the variable on one side and its value on the other side. So here we go. So I'm going to start by getting rid of or neutralizing this 3n on the right side. So I've got positive 3n, so I'm going to subtract 3n here, and I'm going to subtract 3n here. Okay? And when I do my subtraction, 6n minus 3n is 3n, minus 1 is greater than, that's nothing, greater than 8. It's a positive 8. Okay? Now, my next step is if I'm going to have my variables, my n's on the left, I'm going to want my values on the right. So I'm going to deal with this negative 1. So I'm going to add 1 to get rid of it. And I'm going to do the same thing over here. And negative 1 plus 1 is 0. I'm left with 3n is greater than 9. Okay? How do I get the variable to be alone? Well, 3n, remember, means 3 times n. So I need to use the same value, that's 3, with the opposite operation, which is division. So I'm dividing by 3. 3n divided by 3 gives me n, and n must be greater than 3. So when I graph it, I need to move my inequality sign over here and to the 3, and I see that I have a choice of either making greater than or equal to, less than or less than equal to. I know that in this case this is the correct graph because right here I see that n has to be bigger than 3. It cannot be equal to 3. So I leave this boundary point open to show that it can't be equal to 3, but I'm including every number greater than 3, including decimals. So 3.1, 3.2. All those numbers that are less than 4 but higher than 3 will still work here. Okay? And let's see if we are correct. So let's see, a value of 4 should make this correct. So here we go. 6n minus 1 is greater than 3n plus 8. If I substitute a 4 in here, let's see what happens. 6 times 4 is 24, minus 1, minus 1. 3 times 4 is 12, plus 8. So I end up with 23 on this side, and I end up with 20 on this side, and that's a true statement. 23 is greater than 20. Now, if I had used a 2, hopefully you can see that it would not make a true statement because up here, instead of getting 6 groups of 2, 6 groups of 4, I'd be getting 6 groups of 2, and that would make this number a lot smaller. I have fewer groups of here, but I'd be adding a big constant afterwards, so that would keep this number higher, and so I'd end up with a greater number on my right, which of course would make that untrue here. So that's an example of how you might solve an equation, and then, an inequality, and then graph an inequality that has variables on both sides. The rules are very much the same as for when you solve equations, and you graph what you end up with at the end, your solution set.